Okay, can I get somebody to volunteer to answer question number 1? Go ahead.
You divide first?
Yes. So when you simplify 2 plus 6 divided by 3, the operation you should do first is division. Now that comes from order of operation. Most teachers teach you, please excuse my dear Aunt Sally. I'm not a big fan of that because I think I've seen a lot of students make mistakes on that. Let me explain it a little bit differently. So please excuse my dear Aunt Sally. PEMDAS. Okay? The P stands for parentheses. The E stands for exponents. MD stands for multiply and divide. A and the S stands for add and subtract. Now the reason why I wrote it like this instead of across horizontally is because I often see students say, hey, but multiply is supposed to be before divide. Is that true? No. Multiply and divide are on the same level here, and I have them both in green because it depends on which happens first if you're looking at the problem from left to right. Just like when you're reading a sentence, you go from left to right. Math is the same way. So multiply or divide, you can have divide first. It just depends on what order it is when you're working the problem out from left to right. Does that make sense? So those two are really on the same level, and that's why I wrote it like that. Do you guys understand? Same with add and subtract. You can sometimes subtract before add. It just depends on when it occurs in the expression. Okay, any questions about that? Okay. So, moving along, can I get a volunteer to share with the class their answer for number 2? Yes, in the back? Well, walk me through it. Don't just tell me the answer. Walk me through it.
So first, since for PEMDAS, first is P for parentheses, so I did 19 plus 7 equals 26.
Okay, so you added what was in the parentheses, and that gave you back 26. Very good.
And then I divided it by 2, which gave me 13.
And then I still have this part left over, the divide by 2. Okay, so then 26 divided by 2 gave you 13. Very good. So this all equals 13. Excellent. Everybody got that? Any questions about that problem? Okay. Now, the next problem, I had a few students that got confused about this earlier today. Can somebody volunteer to explain their answer? Rehan?
First, I added negative 14 plus 6.
Okay. Very good. So we have to treat this in the numerator as if there's parentheses around there. We're grouping that. There's not parentheses there, but the numerator, simplify that first. So negative 14, positive 6, what's that going to simplify to? Yep, it's a negative 14 and a positive 6, right? So what's that going to become?
Negative 20.
Negative 20.
Yes.
Now remember our rule about different signs. If they're different signs, what are we supposed to do?
Add, so
If
subtract.
we take the difference. So what's the difference of 14 and 6?
8.
It's going to be 8. And then what's the sign going to be? Which sign are we going to keep from those two numbers?
I think the negative,
Right, and why do you think it's the negative?
because 14 is farther than 0.
Right, negative 14 is farther away from 0 than positive 6, so the negative sign's the one we're going to keep. And then we still have to divide by 2. Okay, so what's the final step, Rehan?
You have to divide negative 8 divided by 2.
And what's that going to be?
Negative 4.
Negative 4. And why'd you say negative 4?
Because 8 is farther than 0.
No, not because of that. Now we got to go back to if they're different signs, the quotient sign's going to be negative. If they're the same sign, the quotient sign will be positive. Okay? So when we take the division of same signs, positive, different signs, negative. That's why it's a negative 4. Do you understand? Are we good? Okay, and the last problem in the back. I had a hand up earlier. Can you get the last one for me?
Okay, so first I did negative 9 plus 4.
Okay, we have a dot there. What's the dot signify? right? And remember, order of operation, we're not going to handle add and subtracts until we get to that first, okay? So let's go ahead and take care of that first. What's the sign of 2? Okay, so we have a positive 4 times a positive 2, and a positive 4 times a positive 2 is what?
8.
What kind of 8?
Positive 8.
Now we have what's left over. We're going to bring down what's left over. Now what's next?
So negative 9 plus 8 is negative 1.
Right. They're different signs, so we take the difference of the numbers. 9 and 8, the difference is 1, and we keep the sign of the larger magnitude. Negative 9 is farther from 0, so it's going to be a negative 1. But now I have this left over here, right? So this other number, minus 1. So now I have minus 1, minus 1. What's that going to be?
0.
No, they're the same sign. So what do you do when they have the same sign? They're helping each other out, right? So they're going the same direction. And same sign means we add the numbers. So what do we get? So this equals 2, and it's a negative sign. We keep it. Okay? Are we good? Is there any question about that? That was tripping up a few people, so we need to make sure we're practicing that and understanding the rules. Okay, so to my lesson for the day, here are the answers with their explanations. There's the work. Here's what we're doing for the day. I'll review. This is not new material. I had some people tell me in the morning that they started seeing mean, median, mode in the 4th grade. I'm seeing some nods. Can I get a volunteer to read through till my example? Yes, go ahead.
What you will learn to describe data using mean, median, mode, and range. New vocabulary: mean, outlier, median, mode, and range. Why learn this? You can use the data to model the past and predict the future. School officials use averages to predict how many new students will enroll next year. What averages the mean, which is the sum of the data divided by the number of the data items. A synonym for mean is the word average.
Okay, so I need you to look at the data in the graph. I need you to find the mean. So we just read the steps. Let's see if you guys can get this worked out on your own. We'll discuss it here in a moment. Okay, who can walk us through the first step? What's the first step? So we're going to add all the numbers. We're going to take the sum, all of the data. So when we take the sum of all the data, what did you get when you took the sum of all the data?
I got 95.
Yes. So the sum of all the data was 95. That's correct. Okay. What's the next step? Goldus?
You divide it into 5 because there's 5
There's
There are 5 here.
there's 5 years, but that works here. But there's more correctly is there's 5 data values. Okay. Are we good? So we have 5 data values. We're taking the average or the mean. We're going to divide by 5. So Goldis, what did you get when you divided by 5?
I got 15.
19. Let's double check, because whenever you have,
Oh yeah, because 45 divided by
right, 95, first in the house, second outside the house. Five goes into 9 once. 1 times 5, 5. Subtract, I get 4. Bring down the 5. 5 goes into 45, 9 times. 9 times 5, 45. Subtract 0. Okay? Any question about that problem? Okay. Now, try this one. Okay, who wants to share their results? Mr. Harrington.
First, I added
Mm-hmm. What'd you get?
896.
Very good. Then the next step.
Then I divide by the total
Data values, okay, or data elements. There's a number of ways to say it. Okay, and how many were there?
4.
Okay, so you're going to divide the sum by 4. You're correct. And what did you get when you divided by 4? 224? I think I got the same thing. Everybody got that? Any question? If you have to do the long division, go ahead and do it. Okay? Do you have a question? Okay. All right, moving on. All right. Okay, so I want to talk about this line, this number line. If you notice, you have these dots that are kind of clustered over here, and then I have this dot that's kind of away. This is the graph of the data from our chart. What stands out here when you look at the data? Yes?
The fourth year where there's only 5 students.
So we have all these years where we have 20-something students, new students, and then we have this one year where it's really low, right? That's called an outlier. And so let me ask you this question. Suppose all year long you're getting 90s, 92s, 95s, caught a couple hundreds, and then you got one grade that was just terrible. It was a 15%. Yeah, that's an outlier. Now let me ask you this question. What's that going to do to your average, assessment average? It's going to bring it down, right? Let's think about the opposite. Let's suppose we're really struggling in math. You're getting 30s, some 40s, 45, 32, and then there's a unit of things you knew really well, and you got an 82. Now you have an outlier. Is that going to, what's that going to do to your average then? It's going to boost it up, right? Okay, so fast forward to the definition here. Can I get somebody to read the definition? Somebody I haven't heard from yet. Athila? Did I remember it this time? Yes. Can you read this, please?
An outlier is a data item that is much higher or lower than the other items in the set data. In the data set from the previous example, 5 is an outlier. See the other one?
Mm-hmm.
Since 5 is far less than the other values, the outlier decreases the mean. When a set of data has outliers, the mean may not be the best measure for describing the data.
Okay. All right. Any questions about what an outlier is? We know what an outlier is? Okay, so next thing we need to talk about is the median. Can I get somebody to read about median? Somebody I haven't heard from yet.
The median of the data set is the middle value for the data on a range in numerical order. The median of the set always separates the data in two groups of equal size. The median for an even number of data items is the mean of two median values.
Okay, so let me explain to you what median does. First of all, I've seen this more often than I care to have seen this. Students will forget to arrange the set from least to greatest before they do the next step, which is find the middle number. And most of the time they're wrong. Okay, so the easiest part is the first step, least to greatest. Okay? What the median does is it breaks the set into two equal parts. It's kind of like a knife that cuts things into parts, but this median cuts the data right in half. Now sometimes that median, that number that breaks the data into two equal halves of data, sometimes that number is in the set, sometimes you have to make the number. If the number is in the set, it's when you have an odd number of data elements. If it's an even number, there is no number in the middle, you have to make it. And the way you make it is you take the average of the two closest to the middle. So I just verbally explained it to you, but now let me show you what I mean. Bakar, what's your question? So if you guys don't mind, here's the data set, 20 responses to how many times a day you drink from the water fountain. If you could, first step, arrange at least to greatest. Second step, find the middle number. If there is no middle number, you're going to make one by taking the average of the two closest to the middle. What was your question? Do you have a question? Can somebody walk me through this? Somebody I haven't heard from yet? Ben? Can you walk me through this?
Oh, the first and the way you want me to do it.
Well, what's the first thing we have to do, Ben?
Oh, I make a list of all of the numbers up there.
Okay. And is it a list just anyway?
No, I look and see what numbers are there, and then I write them.
Okay, how do you write them? Just anyway? Any order?
Least to greatest.
There you go. Least to greatest. Can you give me from least to greatest the numbers that are in the table?
0, 1, 2, 3.
Okay, 0. How many ones? How many ones did we have? 3 of them. Okay, you guys agree with that? 3 ones? Okay, then what's the next number up? 2. How many 2s did we have? 6 of them. Do you guys agree there's 6 2s? And I'm running out of space, so give me a moment.
I think it's only 5 2. Okay. 1. Let me count the board.
Look, 1 right there, 2 right there, 3 right there, 4 right there, 5 right there, 6.
So if you're methodical, you won't miss them. Rayhan, just go by column. So I had 2 here, 1, that's 3. There's 1, that's 4, and there's 2 in the last column, that's 6. Okay, after the 2s, what's the next number up? Ben?
3,
How many 3s do I have?
2.
Just 2?
No, they're 3.
Okay. I have 3 3s, and then after 3, how many do I have?
4.
I have a 4. How many 4s?
1.
1. And then after 4, how many do I have of the next number? I have how many? What's the number?
5.
5, and how many are there?
5.
Okay, and then what else do I have?
10.
Okay, how many 10s?
1.
Okay, so I have my lists. Okay, what's the next thing I need to do? Osmond, can you help him out? Right, we cross off the numbers from both sides because we're trying to figure out where the middle is. And I've always shown my students this way. You might have another way. I always taught them to cross off in opposite directions so that we know where they line up in the middle. So here, I got 2 on each side. I continue. And I should have the same slashes on both sides if I count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9 on the left. 1, 2, 3, 4, 5, 6, 7, 8, 9 on the right. And then I have these 2 in the middle. I don't have one number in the middle, I have 2 in the middle. So if I'm going to get a median, I have to make it. Do you guys understand? And the way you make the median is you take the average of the 2 in the middle. And so if we average 2 numbers, what are we doing? You're going to add them together and half it, divide by 2. You divide by 2 because you're taking the average of 2 numbers. Okay? So let's go ahead and walk through that. I have 2 plus 3 divided by 2. What's 2 plus 3? 5. Divided by 2. Well, if you don't know how to convert that to a decimal mentally, let's go ahead and do it. Which one's inside the house? The 5. And the 2 is outside of the house, so let's go ahead. And 2 goes into 5 how many times? It goes in twice. Who said twice? Twice? And then what's that give me back? 4. And what do I have left over?
1.
And then put a decimal and a 0. Bring your decimal straight up. Bring my 0 down. How many times does 2 go into 0?
5.
5 times. So 5 times 2 is 10. Subtract, that's 0, 2, and 5/10. So if you notice, that'll sit right between 2 and 3, right? So 2 and 5/10 breaks my set into 2 equal parts. You guys understand?
Yeah.
And I need you to think about the median as it cuts the set into 2 equal parts, because we're going to be doing box whisker plots. And if you think about it as cutting it into 2 equal parts, box whisker plots are very easy. It's going to make it's going to make perfect sense. So here's a little more detailed explanation for you. That's just the work I showed you above. Now what I'd like for you to do is calculate this set. And I had a number of mistakes because of the negatives. So if you need the number line I have posted up, use it. Remember, further left on the number line is smaller. Okay, who can give me the list? Yes, go ahead.
-18,
Correct. -18, then what?
-5,
Uh-huh.
-2,
-2.
-1,
Mm-hmm.
2, and then 3.
Very good. Now, is the median in the set already? No, because we have even number, we have to make one, right? Now, for a small set like this, you could probably figure out which one your middle ones are, but some of these quizzes and tests you'll take, they'll give you like 15 numbers, so you have to be careful. So the middle 2 numbers are right here. Now you have to be careful because we got to use those rules we learned earlier, okay? We have to take the mean of those 2, right? So what am I supposed to do when I take the mean? What's the first step for taking the mean? Okay, so let's just go ahead, right out the bat. I'm going to put plus, and I'm going to add them together. Tell me what are the ones I'm adding together? -2, and I'm adding that with what? -1. The reason why I'm emphasizing this is kids will forget, because there's a sign already in front of the number, that you're supposed to add them or whatever it is you're supposed to do. So now we have to take all this and do what? What are we going to? We're going to half it, or we're going to divide it by 2 because there's 2 numbers we're finding the average of. So we treat the numerator like it's got parentheses around it. Do I have one set of signs in front of each number? -2, there's how many signs in front of that? How many signs are in front of the 1?
2.
Right, so we got to fix that, right? So let's go and fix that. What's that going to become? Negative, because they're different signs, make them negative. So now I have a -2 minus 1, right? So what's a -2 minus 1? Are they same signs or different signs?
-3.
It's -3. Same signs, you add them, so you get 3, and you keep the sign -3. Okay, very good. And now we're going to divide all that by 2. We need to divide all that by 2. Some of you guys can mentally do it. I know that some of you, most of you can, but just for the sake of having this in the notes, which number is inside the house? The 3, and it's the negative, yes. And outside the house is the one on the bottom, 2. How many times does 2 go into 3? 1 time. 1 times 2. Subtract that, I get, now I got to put a decimal and a 0, bring it up, bring down my 0. How many times 2 go into 10? 5 times. 5 times 2 is 10. Subtract, we have 0. So the answer, what is the answer going to be? Now be careful. There you go. Who said that? Why is it going to be negative 1 and 5 tenths?
Because since the 3 is negative and the 2 is positive, since they're different signs, it has to be negative.
Right. So the answer is negative 1.5. Because you're dividing a negative and a positive. You guys understand? Are we good? Okay, any questions about that? All right, here's an easy one. Mode. Super easy, but there's a scenario where students really get confused. Sometimes you have no mode. That's what throws people off. And it has to do with how the data repeats. So can I get somebody to read through the first, through the definition? Yes.
The mode of the data set is the item that occurs with the greatest frequency. A set of data might have more than one mode. There is no mode when all of the data items occur the same number of times. The mode is a useful measure for data with values that are repetitive or non-numeric.
So let me summarize what that says. The mode is the number that repeats the most. You can have a tie for the most. That means you would have more than one mode. But if all the numbers, all the different possible numbers repeat the same amount of times, if they all have a tie for the most, then there's no mode. If none of them repeat, there's no mode. I often see students say 0 when they mean no mode. If you're saying 0 is the mode, what are you saying? You're saying 0 is repeating the most. If there's no mode, you write no mode. Do you understand? Okay, so let's take a look at this example, finding the mode. Here's a table, and they want you to organize it using a tally chart. So we're going to organize the data. So really quickly, make a quick chart, tally your data, determine which one's your mode. Okay. How many roses are there? So we have 10 people that were surveyed, and these are the answers they gave. So I have this chart down here at the bottom. How many people chose rose as their favorite?
3.
We see 3. 1, 2, 3. These are tally marks. How many people chose pansies as their favorite flower? We see 2. 1, 2. And then peony? How many people chose peony?
1.
Only 1. How many chose daisy?
3.
3. 1, 2, 3. And how many chose orchids?
1.
Only one person liked orchids the most. So what was my mode?
Rose and daisy.
Roses and daisies. So rose and daisy. So my mode rose, daisy. Any questions? Pretty easy. All right, so I think in order to understand it fully, you need to do a couple more examples. So take a look at these examples right here and try to work those out. Okay, for A, I'm going to give you a strategy. Arrange it from least to greatest. I know you're not doing median, but if you arrange it from least to greatest, it's much more obvious what the mode is. Does that make sense? And a lot of times these quizzes will have you calculate mode and mean and the median. So go ahead and arrange it least to greatest. You've already got most of the work done for median, and it makes it easier for mode. So who can tell me what the mode is for the first example? All the way in the back. 17. Do you guys agree 17? 17 happens 3 times, 16 happens twice, 18 happens once. The mode is 17. Now for the next one, who's got the next one? Yes, Dominique? There's no mode. And the reason why there's no mode is what? They all repeat the same amount. They all repeat twice. So there's no mode. Now, if 2 of the numbers repeated twice and 1 didn't repeat at all, the 2 numbers that repeated would be the mode. But as soon as all the possible values repeated the same amount, there's no mode. If they don't repeat at all, there's no mode. Okay, are we clear on that? And the last one, who's got the last one? That was a pretty easy one. What is it, Osmond? Pen, correct. Okay, we're almost done. Last thing I need to talk to you, and let me go ahead and erase this. I meant to erase it, I apologize. Can somebody please read the definition of range? Yes.
The range of a data set is the difference between the greatest and the least value. The range describes the spread of the data. You find the range by subtracting the least value from the greatest value.
Okay, so they're saying already you have to subtract the least, and key word here, from the greatest. So the first number, is that going to be the least number or the greatest number? If I was writing out a number sentence, what would be the first number? It'd be the greatest. So you have greatest minus least. But the way they worded it throws a lot of students off. Do you guys understand? Okay. So if you take a look at this example, some place in Russia, I'm not even going to try to pronounce that place in Russia. The temperature ranges from negative 90 degrees Fahrenheit all the way up to 98 degrees Fahrenheit. So we already know we have to take the difference when we find the range, right? So let's go in and put the minus there. What is the greatest value? Class, what's the greatest value? 98. So 98 degrees. And the least value is negative 90 degrees. Now I want you to think about this conceptually. Okay, look at my number line. 98 would be over here. Negative 90 would be way over there somewhere, right? So now I want you guys to understand the rules I've been trying to show you. What's the sign of 98 if there's no sign? Okay. How many signs are in front of 90? 2. I need to make them into one sign. So what's that sign going to be? Plus. So when they have the same signs, what do we do with the magnitudes? We add them. What's 98 and 90? 188 degrees. And is it going to be a plus or a minus? Positive. Same sign, add them and keep the sign. So if you look at the gap between where negative 90 would be, and 98, do you guys understand how the rules are working? Okay. Last example. If you guys could work that out, please.
Wait a minute, for numbers that one. But when you do 98, you go all the way to 0. It's going to be 98.
Well, think about it. If I go from 98 to 0, that's already 98, right? But then to get to negative 90, I got to go another 90. Do you understand? Does that make sense? So they want to know what's the gap from one to the other. What's the range? Do you understand now? Okay, I need you guys to go ahead and work this next one out. Okay, so who's got the answer for me? And walk me through it. Daniel, walk me through this. What is we have to take the difference. We already know that. So we're going to subtract two things. I need to know what is the highest first, because I have to subtract from the largest, the greatest value, the least value. So what's the greatest value? No, that's when it happened. Look, they're talking about the temperatures. Right, 120. So I got 120 degrees. And then what is the smallest amount? Right, so I got negative 23. And then let's go and make this calculation. Let's fix this. Is there a sign in front of 120? I could put one there. What's going to be? If there's no sign, I can put a plus. Now, these two I got to combine. What can I make them into? A plus, right? And so I have 120 plus 23. What's that going to be? When I add those together, what do I get back? Goldus? 143 degrees positive. Okay, really quickly, a data that can generally affect the mean of a set is called a what? Outlier. If you increase every number in a data set by 2, what will happen to the mean? It'll increase, but by how much? By 2. Next one. A data set consists of the integers 1 through 9. What is the median of the data set? How many numbers in the set if I have from 1 through 9? 9. So do I have to make a mean? A median? No. Least to greatest? My median is in the set. It is 5. Do you understand? I don't have to make one. It's there. A data set has a mean of 3, a median of 4, and a mode of 5. Which number must be in the data set?
4.
No, the median isn't always in the set. 5, because the mode is what happens the most. And 3, is 3 always going to be in the set if it's the mean? No, because when we calculate the mean, it doesn't necessarily have to be in the set. Is mean or median better for describing this data? Take a look at it. Is there an outlier here? What do we say about outliers? Can we use mean? Is it good to use a mean if we have an outlier? No, so we were going to say median. Okay, and that's it. I'll post these up on the bulletin board. If you guys can gather your things together, make sure you do the homework this weekend.
This lesson was recorded already.
And you guys are dismissed. Head out. I do have it. I got to send an email to you. I just haven't had a chance to yet. I've had a few. I've been sending out. I just haven't gotten to yours specifically. Next class.